Standard network devices. Repeater. Hub. Bridge. Switch. Router. Gateway. Brouter, bridging router. NIC. Standard network devices. Network devices. Network devices, also known as networking hardware, are physical devices that allow hardware on a computer network to communicate and interact with one another. At their core, network devices are communication devices. They are the required components for communication and interaction between hardware on a computer network that could be electronic devices like fax machines, computers, printers, and other IT infrastructure. The primary purpose of network devices is to transmit and receive data quickly and securely. Network devices is a broad term that encompasses a range of communication equipment including hubs, switches, routers, bridges, gateways, load balancers, modems, repeaters, and more. Standard network devices. Repeater. A repeater operates at the physical layer. Its job is to regenerate the signal over the same network before the signal becomes too weak or corrupted to extend the length to which the signal can be transmitted over the same network. An important point to be noted about repeaters is that they not only amplify the signal but also regenerate it. When the signal becomes weak, they copy it bit by bit and regenerate it at its star topology connectors connecting following the original strength. It is a two-port device. Standard network devices. Hub. A hub is a basically multi-port repeater. A hub connects multiple wires coming from different branches, for example, the connector in star topology which connects different stations. Hubs cannot filter data, so data packets are sent to all connected devices. In other words, the collision domain of all hosts connected through hub remains one. Also, they do not have the intelligence to find out the best path for data packets, which leads to inefficiencies and wastage. Standard network devices. Hub, CONT. Types of hub. Active hub. These are the hubs that have their power supply and can clean, boost, and relay the signal along with the network. It serves both as a repeater as well as a wiring center. These are used to extend the maximum distance between nodes. Passive hub. These are the hubs that collect wiring from nodes and power supply from the active hub. These hubs relay signals onto the network without cleaning and boosting them and can't be used to extend the distance between nodes. Intelligent hub. It works like an active hub and includes remote management capabilities. They also provide flexible data rates to network devices. It also enables an administrator to monitor the traffic passing through the hub and to configure each port in the hub. Bridge. A bridge operates at the data link layer. A bridge is a repeater, with add-on the functionality of filtering content by reading the MAC addresses of the source and destination. It is also used for interconnecting two LANs working on the same protocol. It has a single input and single output port, thus making it a two-port device. Bridge, CONT. Types of bridges. Transparent bridges. These are the bridge in which the stations are completely unaware of the bridge's existence, i.e. whether or not a bridge is added or deleted from the network, reconfiguration of the stations is unnecessary. These bridges make use of two processes, i.e. bridge forwarding and bridge learning. Source routing bridges. In these bridges, routing operation is performed by the source station and the frame specifies which route to follow. The host can discover the frame by sending a special frame called the discovery frame, which spreads through the entire network using all possible paths to the destination. Standard network devices. Switch. A switch is a multi-port bridge with a buffer and a design that can boost its efficiency. A large number of ports imply less traffic and performance. A switch is a data link layer device. The switch can perform error checking before forwarding data, which makes it very efficient as it does not forward packets that have errors and forward good packets selectively to the correct port only. In other words, the switch divides the collision domain of hosts, but the broadcast domain remains the same. Types of switches. Unmanaged switches. These switches have a simple plug-and-play design and do not offer advanced configuration options. They are suitable for small networks or for use as expansion to larger network. Managed switches offer advanced configuration options. They are suitable for larger, more complex networks and allow for centralized management. Standard network devices. Smart switches have features similar to managed switches but are typically easier to set up and manage. Suitable for small to medium-sized networks. Layer 2 switches operate at data link layer of the OSI model, responsible for forwarding data between devices on the same network segment. Layer 3 switches operate at the network layer of the OSI model and can route data between different network segments. They are more advanced than Layer 2 switches and are often used in larger, more complex networks. PoE switches have power over Ethernet capabilities, which allows them to supply power to network devices over the same cable that carries data. Gigabit switches support gigabit Ethernet speeds, which are faster than traditional Ethernet speeds. Rack-mounted switches are designed to be mounted in a server rack and are suitable for use in data centers or other large networks. Desktop switches are designed for use on a desktop or in a small office environment and are typically smaller in size than rack-mounted switches. Modular switches have modular design, which allows for easy expansion or customization. They are suitable for large networks and data centers. Standard network devices. Router. A router is a device like a switch that routes data packets based on their IP addresses. The router is mainly a network layer device. Routers normally connect LANs and WANs and have a dynamically updating routing table based on which they make decisions on routing the data packets. The router divides the broadcast domains of hosts connected through it. Standard network devices. Gateway. A gateway, as the name suggests, is a passage to connect two networks that may work upon different networking models. They work as messenger agents that take data from one system, interpret it, and transfer it to another system. Gateways are also called protocol converters and can operate at any network layer. Gateways are generally more complex than switches or routers. Standard network devices. Brouter, bridging router. It is also known as the bridging router is a device that combines features of both bridge and router. It can work either at the data link layer or a network layer. Working as a router, it is capable of routing packets across networks, and working as the bridge, it is capable of filtering local area network traffic. Standard network devices. Network interface card. NIC or network interface card is a network adapter that is used to connect the computer to the network. It is installed in the computer to establish a LAN. It has a unique ID that is written on the chip, and it has a connector to connect the cable to it. The cable acts as an interface between the computer and the router or modem. NIC card is a layer 2 device, which means that it works on both the physical and data link layers of the network model. Network devices.